A rotation turns a figure a given number of degrees around a point. That is usually the origin, but it could be any point. So what I want you to know is that the pre-image, every single time that we turn it 90 degrees, we move from one quadrant in the coordinate plane to another. So 90 degrees clockwise would be into the fourth quadrant, and 90 degrees clockwise again into the third, and 90 degrees into the second, and then going back 90 degrees, we are back where we started. In this table here, it also tells you what happens to the coordinates. You should memorize this, and we will get back to it to think about some tricks to make that easier. So let's look at the example on the left. Here we're supposed to rotate the triangle 90 degrees counterclockwise about the origin. 90 degrees counterclockwise means that we're going against the clock into the next quadrant. And when we do that, one way that helps visualizing our rotation is to draw a line from the origin to the closest point of our object, in this case our triangle. It's almost like a handle or a popsicle stick, and that helps us perform our rotation more easily. So let's take our object then and rotate it around the origin, and as you see, our coordinate plane, our axes go with it. And now that our axes match again, our object has been rotated 90 degrees, which you can also tell from looking at our handle here, and the two form a right angle of 90 degrees. So what are the coordinates of our pre-image? Our first point here has the coordinates 2, 2. The next point has the coordinates 5, 1. And our uppermost point has the coordinates 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, and 6. And looking at our image, what are the coordinates here? Negative 2 and 2, negative 1, 2, 3, 4, 5, 6, negative 6, and 1, 2, 3, 4. And our third point has the coordinates negative 1 and 1, 2, 3, 4, 5 up. We went 90 degrees counterclockwise as in our first box up here, and as you can see, the coordinates got switched and the y coordinate became negative. Let's go to our next example. Now we're supposed to rotate the triangle 270 degrees counterclockwise about the origin. 270 degrees counterclockwise, so we go 90 degrees, another 90 degrees, and another 90 degrees, and we end up in the first quadrant. 90 times 3 is 270. Let's draw a popsicle stick here. And now we're going to rotate our triangle 90 degrees counterclockwise, another 90 degrees counterclockwise, and another time 90 degrees counterclockwise. Here we are. So what were the coordinates of our pre-image? 1, 2, 3, 4, 5 to the left, negative 5 and 1, negative 1 and 2, and negative 1 and 5. Now let's look at the coordinates of our image. 2 and 1, 1, 2, 3, 4, 5, 5 and 1, and 1 and 1, 2, 3, 4, 5, 1 and 5. If you look at the corresponding points, you see that now the y's and the x's switched again, but now the x's also switch the sign. So essentially, for every 90-degree rotation, the x's and y's switch places. For every 90-degree rotation, the x and the y switches. And for the positives and negatives, just think about which quadrant of the coordinate plane does the figure land in. Let's move on to translations. A translation is a slide that moves every point of a figure the same distance in the same direction. Let's look at our picture here on the left. Point A moves to the right and then down to get to point A prime, and point B moves the same distance to the right and then the same distance down to get to point B prime, and point C moves the same distance to the right and the same distance down to get to point C prime. Let's look at our example here on the right. The vertices of triangle AB are A with coordinates 1, 1, B with coordinates 3, 4, and C with coordinates 5, 0. Graph the pre-image and the image by translating left 3 units and up 2 units. Then write the coordinates of triangle A prime, B prime, C prime. Starting with triangle ABC, our points are at 1, 1, B is at 3, 4, and C is at 5, 0. And now we are going to move each point 3 steps to the left and 2 steps up. So going from A, 1, 2, 3 to the left and 2 up, we get to A prime. From B, 3 steps to the left, 2 steps up, we get to B prime. And from C, 3 steps to the left and 2 steps up, we get to C prime. Here is our triangle, and as you can see very well, it looks just like our triangle ABC has been moved to the up, to the left and up. And now we're going to write the coordinates of our triangle A prime, B prime, C prime. A prime is at -2 and 3. B prime is at 0 and 5. And C prime is at 2 and 1. And if you look a little close at our coordinates, the x-coordinates have been achieved by subtracting 3 from each one of our original x-coordinates. That's what left 3 means. And the y-coordinates have been added by 2 because we moved the triangle 2 steps up. Of course, we can also combine 2 different types of transformations. In this example, triangle FMA is reflected about the y-axis first, and then it is translated up 9 units. What are the coordinates of point M prime after the transformation? So the y-axis is our line of reflection, or remember, we also called it a mirror. This is our line of reflection. That means that our point M has to go the same distance to the other side of that line of reflection. So we are 1, 2, 3, 4, 5, 6 steps away from a line of reflection. That means we have to also move 1, 2, 3, 4, 5, 6 steps to the other side. And there is our M prime for now. And then we are translating it up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is where our M prime finally lands. And we're supposed to tell the coordinates of that point. And here we start, of course, with our origin. 1, 2, 3, 4, 5, 6. To the left is negative 6. And 1, 2, 3, 4, 5, 6, 7 up. Negative 6 and 7 are the coordinates of point M prime. Alright, you guys, that's it for today, and I will see you in class.